Okay, so 2 videos in one day. Welcome to 2021. This is your rational exponents. This should be in your ISN, probably page 73. If it's not put together, cut the pages in half, then fold them so you can see the words vocabulary, positive, negative. And then when you open it up, what you're going to see are these definitions about rational exponents. Rational isn't a new word for us. We know that a rational number, if we think about it, this is a fraction. It can be written in fractional form. So if something has a rational exponent, it's going to look like x to the 1/2 or x to the 1/3. These are rational numbers. It could even look like some number like 27 to the power of 2/3. If it is written as a fraction, it is considered a rational exponent. We can also rewrite these exponents that are fractions in radical form. And remember, all a radical sign is this, with the index number here of which root you're taking it. So x to the 1/2 is the same as the square root of x. X to the 1/3 is the exact same as the cubed root of whatever you've multiplied 3 times. If you have a number like 27 to the 2/3, that means you are taking the cubed root of 27 and then you are squaring it, right? If you think about this fraction, 2 is the same as 2/3 is the same as 2 times 1/3. So you took the cubed root of 27 and then you squared it. And that's what rational and exponential form means. So in algebra, we could have the base b to the power x, y. That's the rational exponent. The radical form then means it's the y root. Okay, that's the index, so squared or cubed root of b to the power of x. This is going to be the same thing as taking the y root of this number and then raising it to the power of x, because if you raise a power to a power, you're multiplying. So that would be the same thing. All right, so those notes should go into your ISN when you have that foldable together. Now we're going to look at some examples. I'm going to start you. And then I'm going to let you finish the rest of them on your own. That's what you'll do for the rest of your homework time. So what we said is that taking the square root of 1/2 is the same as taking, or 16 to the power of 1/2 is the same as the square root of 16. Okay, we think about square root of 16, it's a perfect square. It is 4 squared, and if you multiply that to the root of 1/2, I'm just going to rewrite it in exponential form, right? A power raised to a power, you multiplied. Well, 1/2 of 2 is going to be 1, so it's 4 to the power of 1. Okay? A half is taking a square root, so I'll let you do example 2 by yourself. Let's look at example 3. This is going to be the square root of 9, because it's to the half. We're going to think about this as 9 to the 5th times 1/2. You have to take the square root, and then you're going to raise it to the power of 5. The square root of 9, why I did that one first is because I know that the square root of 9 is 3, and then I can raise that to the 5th power, and I am going to get 243 as my simplified answer. Okay, one more. This is the cubed root. We're going to think about 64, and we're going to do the cubed root of it. So it's going to be raised to the 1/3, only because I know what the cubed root of 64 is. Then we're going to raise that answer to the 4th. The cubed root of 64 means 4 times 4 is 16. Times it by another 4. If I take the cubed root of that, that's 64. Okay, then I'm going to raise that answer. So the cubed root of 64 is 4. I'm going to raise that to the power of 4. So 4 times 4 times 4 times 4, or I will get 256. Okay, try 2, 4, and 6 on your own to see if you get the hang of those. All right, this is the index. You're taking the cubed root and then you're squaring it. Okay, If you flip to the next page, I'm going to do a couple examples with negative exponents. What we should remember about negative exponents was the rule was x to the negative m is the same as 1 over x to the positive m. It means that root was left over in the denominator. So this is the same as writing 1/2 is the square root, right? That's taking the second root of 25 to the, but it's going to be over 1. Oh, I kind of jumped the gun there. So I can rewrite this as 1 over 25 to the power of 1/2. The power of 1/2 is the same as taking the square root. So this will reduce to 1/5. Okay, so the first thing, if I see a negative root, I am going to rewrite that because I can find the positive root of something. I can't find the negative root of it. This means this is 1 over 4 cubed and the square root of that. So this is the same as taking the square root of 4, right? That's an index of 2. We don't write that when we have a square root. And then I'm going to cube it. Well, the square root of 4 is going to be 1 over 2. Then I take it, raise it to the power of 3. This is equal to 1/8. Okay. One more example. I am going to do example 11. This is a cubed root, but because it is a negative, I need to rewrite it with a positive exponent. It's going to be 8 over 1/3, or 1 over 8 to the power of 1/3. All right, that means I am taking the cubed root. That denominator is the root of 8. What did I multiply 3 times to get 8? 2 times 2 times 2 is 8. So this is going to be the exact same as, or equivalent, equal to 1/2, 0.5. Try 8, 10, and 12. And that was my short video.